Now there is another way to solve such questions containing linear equations with constant coefficients which are not homogeneous. If we have any function of differential operator d y equals q, then we can find its particular solution as 1 upon f dq. So using this part, we can find YH and we can find YP using this condition. How do we use this? Let us take an example. Say for example, we would find y double dash minus 3y dash plus 2y, and this is equal to e to the power x. Now we can write it in terms of differential operator as d square minus 3d plus 2y equals e to the power x. Now first we'll find solution to this homogeneous equation, and for that we'll write d square minus 3d plus 2 equals to 0. So we get d as 1 and d as 2. So in this case YH will be simply c1 e to the power x plus c2 e to the power 2x. Now we can write this as yp equals 1 upon d square minus 3d plus 2 e to the power x. Now we can factorize this as 1 upon d minus 1 d minus 2 e to the power x, or we can write this as 1 upon d minus 1 into 1 upon d minus 2 e to the power x. Now what we'll do is first we'll solve this. So we'll let u equals 1 upon d minus 2 e to the power x. Now this is u dash minus 2u equals e to the power x, which is nothing but a linear differential equation in first order in u. Its integrating factor will be e to the power minus 2 dx, so it will be e to the power minus 2x. So we can write u into e to the power minus 2x integral of e to the power x and e to the power minus 2x. That will be e to the power minus x dx. So u e to the power minus 2x will be minus e to the power minus x, or this u will be minus e to the power x. Now we'll put the value of u here. So this yp will be 1 upon d minus 1, and this is minus e to the power x. Now we can write y dash p minus yp, it is minus e to the power minus x. Now this is linear in yp, its integrating factor will be e to the power minus integration of dx, so it will be e to the power minus x. So you can write yp e to the power minus x, and then it will be minus e to the power x into e to the power minus x, it will be simply 1. Now we'll take e to the power minus x on the right hand side, so it will be this yp equals minus x into, so our yp is minus x into e to the power x. So now we have yp as minus x into e to the power x, and once we have yh and yp, we can write its general solution as y equals yh, so it will be this c1 e to the power x plus c2 e to the power 2x minus x into e to the power x. Now there is actually a shortcut for this. If you can remember the formula, we can use the shortcut directly. So if we have this y as 1 upon d minus m1 into 1 upon d minus m2, 1 upon d minus m3 up to 1 upon d minus mn, and then this function q, we can establish a direct formula which is y equals e to the power m1x integral of e to the power m2 minus m1x into integral of e to the power m3 minus m2x integral, and I will continue up to integral of e to the power mn minus 1 into integral of q into e to the power minus mnx and this dx to the power n for each of these n integrals. Now how do we use this? So we'll solve this previous question using this shortcut. Now question was d square minus 3d plus 2 y, this is equal to e to the power x. Now we have already calculated its homogeneous part, so value of d is 1 and 2. So YH, it was C1 e to the power x plus C2 e to the power 2x. Now we can write this YP as 1 upon d minus 1 d minus 2 into e to the power x. Now here m1 is 1 and m2 is 2 and q is e to the power x. Now we are going to write this direct formula. So it is e to the power m1x. Now m1 here is 1 and m2 is 2. We have to arrange them in ascending order. So it will be this e to the power x and then integral of e to the power m2 minus m1. So it will be this e to the power x and then this integral of q, which is e to the power x into e to the power minus mnx. Mn in this case is 2. So it will be e to the power minus 2x into dx square. Now this is e to the power minus x and e to the power minus x is minus e to the power minus x. So it will be this e to the power x and then integral of e to the power x minus e to the power minus x into dx. Now this is 1. So it will be minus x into e to the power x. So in this case yp is simply minus x into e to the power x. So we have yh and we also have yp. So we can write its solution as c1 e to the power x plus c2 e to the power 2x minus x into e to the power x. Now let us take another example. Now the question is d cube minus 5d square plus 8d minus 4 into y, and it is equal to e to the power 2x. Now this is homogeneous part. So d cube minus 5d square plus 8d minus 4 equals to 0. We have solved it previously using the method of undetermined coefficients. So we know it will be this d minus 1 and d minus 2 square equals to 0. So we have d equals 1 and d equals 2 and 2. So we know that its yh will be c1 e to the power x plus c2 plus x c3 e to the power 2x. Now we can write this y as 1 upon d minus 1 d minus 2 d minus 2 into e to the power 2x. Now here m1 is 1, m2 is 2, m3 is 2 and q is e to the power 2x. Now we will write yp directly. It will be this e to the power m1x. So it will be this e to the power x and then this integral e to the power m2 minus m1. So there will be e to the power x, and then this integral e to the power m3 minus m2. So there will be e to the power 0, and then q e to the power 2x into e to the power minus m3x. So there will be e to the power minus 2x, and there will be dx cube. Now this is 1, so it will be simply x, and this is also 1, so it will be simply x square by 2. So we get e to the power x as e to the power x into x square by 2 into dx. Now we'll use by parts, so it will be this 1 by 2 e to the power x, and then it will be e to the power x into x square minus integral of e to the power x into 2x dx, and there will be 1 by 2 e to the power x e to the power x into x square minus e to the power x into 2x, and then minus minus plus 2 e to the power x. So we'll take e to the power x out, so it will be this 1 by 2 e to the power 2x x square minus 2x plus 2, and that's your yp. Now general solution is yh plus yp, so we can write y as yh will be c1 e to the power x plus c2 plus x c3 e to the power 2x plus, now here we have e to the power 2x, which is same as this, and we have x and constant term which will be consumed by these coefficients. So all we need to write is this term x square, because it is not there previously. So it will be this 1 by 2 e to the power 2x into x square, and that is the answer to this question. Let us take another example, and this example is solve this equation d square plus 9y, and this is equal to x cos x. Now first we'll find yh, and for that we'll take d square minus 9 equals 0. So we'll have ds plus minus 3 iota. So basically its yh will be c1 cos 3x plus c2 sin 3x. Now we need to find its particular integral, and what we'll do is we'll write this yp as 1 upon d square plus 9 into x cos x. Now what we can do is we can write d square plus 9 as 1 upon d plus 3 iota into d minus 3 iota into this x, and what we'll do is we'll write this cos x in terms of exponential functions. So we can write this as e to the power iota x plus e to the power minus iota x whole divided by 2. Now here m1 it is minus 3 iota, m2 is 3 iota, and q is x into e to the power iota x plus e to the power minus iota x whole divided by 2. Now we can write this y. Now this y will be e to the power m1x, so it will be e to the power minus 3 iota x, and we'll take this 1 by 2 out also, so it will be this 1 by 2 e to the power minus 3 iota x, and then integral of e to the power m2 minus m1, so there will be e to the power 6 iota x integral of, and then we have this q which is x e to the power iota x plus e to the power minus iota x into e to the power minus m2x. So there will be e to the power minus 3 iota x dx square. Now we can write this as 1 by 2 e to the power minus 3 iota x integral of e to the power 6 iota x integral of x into e to the power minus 2 iota x plus e to the power minus 4 iota x into dx square. Now we'll solve it using by parts. So it will be this 1 by 2 e to the power minus 3 iota x e to the power 6 iota x, and then here it will be x as it is, and here will be this e to the power minus 2 iota x upon minus 2 iota plus e to the power minus 4 iota x upon minus 4 iota, and then minus integral of derivative of x is 1, and this integral will be e to the power minus 2 iota x upon minus 2 iota plus e to the power minus 4 iota x upon minus 4 iota dx whole into dx. Now this is 1 by 2 e to the power minus 3 iota x, and then this integral e to the power 6 iota x. Now iota to the power 4 is 1 and minus iota is iota cube, so we can write x, and this is iota e to the power minus 2 iota x whole divided by 2 and plus iota e to the power minus 4 iota x upon 4, and here it will be e to the power minus 2 iota upon 2 iota square. So there will be plus 1 by 4 e to the power minus 2 iota x, and here will be plus 1 by 16 e to the power minus 4 iota x into dx. Now we'll multiply e to the power 6 iota x inside. So it will be this 1 by 2 e to the power minus 3 iota x, and here will be this x into e to the power 4 iota x upon 2 plus e to the power 2 iota x upon 4 into iota, and plus 1 by 4 e to the power 4 iota x plus 1 by 16 e to the power 2 iota x into dx. Now again we are going to use by parts in this first one, so we get 1 by 2 e to the power minus 3 iota x, and here it will be x as it is, and then e to the power 4 iota x upon 8 iota. Now this iota will cancel, so it will be this 8 plus e to the power 2 iota x upon 8, and then minus this integral derivative of x is 1, and here it will be e to the power 4 iota x upon 8 iota plus e to the power 2 iota x upon 8 iota into iota dx, and here it is simply e to the power 4 iota x upon 16 iota plus e to the power 2 iota x upon 32 iota. Now this is 1 by 2 e to the power minus 3 iota x, and it will be this x into e to the power 4 iota x plus e to the power 2 iota x whole divided by 8 minus, now here iota and iota will cancel, so we will get 1 by 8, and here will be e to the power 4 iota x upon 4 iota plus e to the power 2 iota x upon 2 iota, and plus e to the power 4 iota x upon 16 iota plus e to the power 2 iota x upon 32 iota. Now this is 1 by 2 e to the power 3 iota x, this is x e to the power 4 iota x plus e to the power 2 iota x upon 8. Now this is minus 32 and plus 16, so there will be plus 1 by 32 iota e to the power 4 iota x, and this also is 32 iota and minus 16, so there will be minus 1 by 32 iota e to the power 2 iota x. Now we will multiply 1 by 2 e to the power minus 3 iota x inside, so it will be this x, and then it will be e to the power iota x plus e to the power minus iota x upon 16 plus 1 upon 64 iota e to the power iota x minus e to the power minus iota x. Now this is 2 cos x, so it will be this x cos x by 8, and plus this is 2 iota sin x, so there will be 1 by 32 sin x. So this yp, it is x cos x by 8 plus 1 by 32 sin x. So once we have yh and yp, we can write its general solution as yh, and yh is c1 cos 3x plus c2 sin 3x plus x cos x by 8 plus 1 by 32 sin x, and this is how we use this shortcut.